Today we talk about scalable resilient and data streaming with Apache Pulsar. First, I have 3 questions for you. Who is a Kafka user here? Was I am a Kafka user or the same one? Who is a RabbitMQ or ActiveMQ user or anything that ends with an MQ? Okay, 1, 2, okay, great. Who have heard of Pulsar before? Oh, 2. Who is a Pulsar user? The Pulsar nothing. Oh, we're shy of that. Yeah. Oh, right, so we have to start with. Great. Alright, who is the rover? The rover here, or clearly ups. You ups. Right, underneath, and we are on the ghost today. Okay, so I'm opening you to think about my talk, just because at the end I can ask some questions, some reactions, comments, raising your flashes. It's very intensive. Alright, are you ready? So my name is Julien Jakubowski. I work at Scalable on the state to flash this QR code so you get more information about Pulsar, you may get some interesting resources about Rabbit comparison. If you can Pulsar, I see that you have many Pulsar Kafka. Welcome. Join us. And so welcome to the new journals. So I said, please follow my talk carefully because at the end we have a chance to win you. So, for the new journals, who is Kafka user here? Can you raise your hand if you're a Kafka user? Alright. Are you a user of anything that does with MQ, for example, RabbitMQ or ActiveMQ users? Okay, great. There some Pulsar users here? Apache Pulsar users? 1 here, that's all. Okay. Who heard of Pulsar before I talk? Okay, right. We tried Pulsar already. Okay, the task still no Pulsar user we have to talk. Alright. Thank you so much. So, let's start this. So, let's say I'm Julien Jakubowski. I'm the advocate as a native. This is that for the new journals, to further this purpose, we get more resources about Pulsar, and for example, a comparison between Pulsar and Kafka. I'm interested because I know that you are so many people using Kafka. I'm the advocate in Europe for street dating. It's been more than 20 years now that I'm in developer, particularly in Java and Spring. I've built many systems into these Scalable and development systems for rings that found in Swift, for example. And I really believe in North France, so you hear French accents. And I'm also one of the leaders in several technical communities in France, for example in Java, so Lille. So who have heard of this native before? Those arts and individuals. That community was founded by the original creators of Apache Pulsar. Humanity is the last contributor to open source of Apache Pulsar, the entire ecosystem around it. And Streamnative offers Streamnative Cloud, so basically Streamnative Cloud is a fully managed Pulsar service on top of Pulsar, with enterprise schedules on top of Pulsar. Then we can run this Pulsar service on our infrastructure, but also on your infrastructure as well. Alright, so if you want this Apache Pulsar, Apache Pulsar is a cloud-native cloud-native messaging and data streaming platform. What do I mean by cloud-native? Cloud-native means several things. What I mean by Apache Pulsar as a cloud-native platform is that Apache Pulsar is designed to be run in containerized environments. So Apache Pulsar, the Docker Hardness runs, and Apache Pulsar box really breaks with Kubernetes. These are designed from ground up to run on multi-horizon down beginning. And what I can also expect from a cloud-native system is elasticity, but this is also what the cloud is about. Right? Elasticity is about adapting to corporate changes by being able to provide more resources when your workload increases, and at the same time, remove resources when your workload decreases. Right? This is what elasticity is about. And Pulsar is a very elastic platform, as we will see. So Pulsar is a native messaging and data streaming platform, but first let's define what data streaming is in a few words. Data streaming is about continuously transmitting and processing an validated stream of small data ribbons, right? And validated stream of small data ribbons that are interlinked together over time, right? It means that ordering is important. We need to process the records in the right order in the data stream world, right? And those records become often called events because most of the time, this data represents events that happened in the past. All right? Does it speak to you? Get the users there? Okay. And those events, because data may still make transform, it meant aggregating, and maybe also replay. We may need to replay these events, those that occurred in the past, right? You can process those events when they come. You can also reprocess and read them again from the past, right? If the users is to you. Okay. Those data streaming platforms are able to handle massive amounts of data, and they're also throughput. This is why most of them are really scalable. All right? So what is how? Well, can do something that string, for example, data ingestion. So basically, it's about moving a huge amount of data from several sources to different destinations in real time or near real time, right? And it's also about real-time analytics. So the goal here for the real-time analytics to be able to make decisions based on fresh data as the events occurs. So we don't want to wait for a batch process to be on tomorrow. You will be able to make decisions as soon as the event occurs. Right? For example, you can fraud detection, you can inventory stock predictions, you can do surveillance with data with real-time analytics. All right? So some common streaming platforms, you have Apache Kafka, which is a widespread usage, as I can see. We can also mention Amazon Kinesis, that is a fully managed data streaming platform, and Pulsar also the streaming platform as well. I told you that Pulsar is a data streaming and messaging platform, a data streaming and messaging. So then we use the same capabilities that are generated from streaming. We have common points. It's about processing things and consuming things. There is also huge differences between data streaming and messaging. What I mean by messaging and message queuing in particular, let's say that you need to assign time-consuming tasks among a group of workers. So you have a producer system that needs a task to be performed by another system, which is a consumer product. We have producers that ask for tasks to be performed, and consumers that we call producers and workers that will consume those tasks, that you run and perform those tasks, right? So the goal is not to impact the producers. This task may be run independently from the user, and if the consumer goes down, the producer becomes impacted. Or if the consumer is slow, the producer is not impacted as well. All right? This is about decoupling two different systems. This is about messaging useful. So for that, you can implement message queuing. So each task will be represented by one message in one message for one task. So each task you perform is a message placed in a queue, message queue. And the role of the messaging worker, messaging platform, will distribute those tasks among several workers. Right? And contrary to the data streaming, when you do message queuing, you don't have this strict ordering requirements. You don't need the strict ordering requirements when you do messaging. Of course, it's slightly better to be able to process the messages in the right order, but you won't call the system start to message Okay? Because all those messages are independent tasks. They are not interlinked together because they are not tokens in our messages. As it speaks to you, RabbitMQ users, yeah. So, what are the essential features that we can expect from message queuing platforms? We can expect to be able to horizontal scalability and elasticity. You need to be able to add new workers or remove new workers dynamically quickly as well. Because if your message queue is growing, because you don't have enough resources to perform the task, then you need to add new consumers, new workers to the thing to be able to keep up and to consume the remaining tasks faster, right? The point that your queue should be empty or almost empty at any time, right? And at the same time, if you end up with having too many consumers, then you'll be able to remove the consumers, to unprovisioning them, downscale them, to be able to save on infrastructure costs. Okay? Another feature is not to block the queue when the consumer is busy, or when the consumer fails to consume one message. It's very important that when the consumer fails to consume a message, or when the consumer is out, then all the consumer must be able to process the remaining messages without waiting for the consumer to get unblocked. Right? I don't want to permit you. At the same time, I also want to be able to retain failed messages to try later. And sometimes the messages could never be processed. For example, let's say that you have a message that has an invalid format, then you will never be able to process it, and we need to remove this message from the queue and to put it to a tail level queue, right? To speak to RabbitMQ guys, yeah. Okay. So some common message queue platforms and RabbitMQ, that those updates are very well, and I'm sure RabbitMQ is key. We can also mention Amazon S2S and Pulsar, also a messaging queuing platform. So, just quick recap, there are very different requirements for data streaming role and for message queuing role. When you do data streaming, you need to process the data in order. It's very important, but it's not so important to message anymore. When you do data streaming, you will need to ingest large amount of data very quickly. That's not quite the case in message streaming. When you do data streaming, we need to retain this data, or more or less over the time. I mean, there's terabytes of data for 1 year, for example. You don't really do that when you do message streaming. You don't really need that, right? Because when the task is performed, then and the store messages quickly, right? Don't really need to store those messages for a long period of time. With the data streaming, you may also need to handle a big cache upgrade, right? In order to read the message from the past. You also really need that in the message stream. And at the same time, when you do message stream, you need to add a link functional time indicate something important to be able to boost some varying goal. You don't want to bug a queue, you want to make the failing message later. And another feature that's pretty cool is that you might also need to reschedule or delay delivery of messages. That way we insist in the data stream more. Alright? So as you can see, there are very different requirements here. We have common points, but also very different requirements. So in an enterprise and a company, most of the time we end up with two different platforms to that. RabbitMQ to messaging and Kafka to data streaming. It means two different platforms to operate, and two different platforms where your developer also have two different states down. But Pulsar, with Pulsar, we take that decision because Pulsar is able to do both. So with Pulsar, we can only learn one single platform and operate one single platform to do both messaging and data streaming. Alright, so now you could say, well, Julien, come on. Kafka is about messages, right? Kafka is about producing and consuming messages. So you should be able to implement a message queue using Kafka, right? Who are going to try this? I try this. Okay. When I try this, I feel a bit like that. right? Okay, so now we're releasing. It's a bit like trying to, to insert a queue into work around how you can quickly feel that it's not designed for. Right? Why is that? Well, let's try to implement those results in Kafka. So it's a simple with a single topic that will be made of one single partition, and we have only one consumer to start. What if I need to consume the queue faster? So that my queue is growing, more and more messages, so I have to keep up, I need more resources. It would be great if I could ask a new consumer to consume my messages faster, right? So let's try this. Let's try to have a new consumer using the same, what we call the same consumer group with Kafka. What happens here? Can I do that with Kafka? On the same consumer group? No, you can't. Who told that? You will pay you. That seems you couldn't forget. You will get your congratulations. Alright. No, we can't do that. Step down, we can only have one single active consumer per partition and per consumer group. Alright? So if you need to add a new consumer, then you will need to add a new partition. And no storage. And I think the partition topic, for that we need to perform something on the worker side that can be cumbersome, that can be problematic. And you may also need to rebalance data. Across partition, then also not to do that, right? After users will lose me. Okay. So that's sometimes here. You can feel that it's not very designed for elasticity of the consumer side, right? Because we need to plan way in advance every partition you need to be visible with that or etc. That can be a bit difficult and challenging. Now, what if message stay grabs the queue while we end up with the same problem? You will need to add a new consumer, and it will get basically the same problem. We then need also to add a new partition. Because adding a new partition can be cumbersome, you can also lead to downtime, performance loss, or even sometimes downtime, right? So now you could say, that's easy to solve. You just have to add a new partition, right? Problem solved. Is the problem solved? No, it's not. Of course. Let's say that the message blocks here. What will happen is that the second partition will be blocked, but the first one is still blocked. Because we have one consumer associated with partition. Alright? So that's how it's ideal. Clearly, that's how it's done for. We won't use data to perform or messaging. Alright? This is not the same use case, it's not the same semantics. This is what relational message groupers are for. RabbitMQ can do that. Kafka, for now, can internet. For now. Alright. The good news is that this Pulsar can do both. With Pulsar, we can have only one open to manage, one open to operate, and one integrate to learn, and we'll be able to both messaging and data streaming with the same technology. Okay, so that can seem a bit weird because I just told you that data streaming and messaging are quite different, but at the same time, our single technology can do both. How is it possible? It's possible because with Pulsar, well, you will find the same concept on most of the platforms. So we have user, consumer, and what we call topic, which is basically first in, first out, so right? Just like Kafka. But Pulsar introduces an additional concept on top of that. This is the subscription. Pulsar consumer declare how they want to consume messages. And for that, I make what we call a subscription. And the subscription specifies how consumers using the subscription will receive the topic's messages. Subscription tracks which messages are consumed by which consumer, right? In the same subscription. And one topic can have several subscriptions at the same time, which is very important to understand. Alright? With Pulsar, we have 4 subscription types. first one is the exclusive one. With the exclusive one, we have only one single consumer connected to the subscription. Because you have only one single consumer, then we get an ordering guarantee, because there is no reason why the order will not show us, right? Because we have only one single consumer for institution. So if you try to add another consumer to institution, so we reject the connection, reject it. Now the funny, but once if the consumer is down, then we stop the message consumption, right? This is why we also have the failover mode. With the failover mode, you can have several consumers at the same time connecting to the same subscription, but only one consumer will be active. Pulsar will send messages to only one of those. And if this active customer goes down, then Pulsar will instantly switch to another one, okay, as a fallback. So at the same time, we still only have one single active consumer, so we get rather than warranty, but we also have failure. Now what if I need to get several consumers consuming the same messages, just like RabbitMQ? For that, I will use the share subscription mode. Using the share subscription mode, that will do exactly what I described in the messaging and RabbitMQ. Pulsar will deliver each message to one consumer in the round-robin fashion. So the first message will be delivered to the first consumer, the second message will be delivered to the second one, etc. In that mode, this is how RabbitMQ works. For example, you are in the messaging mode, whereas on the other subscription, it's more about data streaming of doing parallel. Right? So, using the share subscription, you may lose the ordering guarantee, because let's say that the first message states take more time to consume than others, then you may end up with consuming the second message before the first one. So you will lose your guarantee. But the benefit is that we benefit from the consumer scalability, because it's very easy to add a consumer, to remove consumer to share subscription. So we automatically manage that, and we automatically distribute the messages to new consumers almost instantly, without the need of creating a new partition. And now, what if I want the best of both worlds? What if I want to benefit from the consumer scalability, and at the same time, I need all the warranty? For that, well, define our model subscription, that is the key share subscription. With the key share point, if producers are able to associate a key to the product messages, then all messaging and all messages sharing the same key will be delivered to the same consumer in the right order. Okay? And so that, I still didn't to create any partition. But I didn't touch my order, I just had to add a new consumer, and that's it, the partition required. Okay? So we benefit from the consumer scalability, or the scalability that on the consumer side, and at the same time we also keep an ordering balance, which is critical. Alright, this is why we say that Pulsar is a unified messaging platform, because using a single technology, you can do both messaging and data streaming. Now, let's delve into the scalability and the elasticity that Pulsar provides, because Pulsar provides 3 levels of scalability and elasticity. So, as a reminder, elasticity is about adjusting your resources to the workload that you have. So if your workload increases, we need to increase the resources, to provision more resources, and if your workload decreases, we need to remove resources, to decommission resources, but key to save the infrastructure cost. So you will pay at any time compared to just what you need by the current workload. Right? This is what elasticity is about. And I can't really say that Kafka is a very elastic solution. It's a scalable solution, but it's not very elastic because with Kafka, you have to plan, carefully plan the partition with the others. That's going to be a difficult. Okay. The scalability requirements are determined by the bottleneck that you have. So you can say that there are three bottlenecks. The first one is the number of messages remaining to be consumed. So let's say that your queue increases, so you need to add more consumers to manage that, right? That's the first bottleneck. The second bottleneck is the number of producers and consumers that connects to your broker. It means that the limit is not the consumer, the limit is the broker by itself. Right? This is another bottleneck. And the third bottleneck is the storage capacity, because when you do data streaming, you may need data retention, so you may need to store terabytes of data, so for more listening time. So your limit may be also the storage capacity. And in Pulsar, you may handle those three limits, but with three different ways. Let's dive into the first one, which is most common. Not all cases, but most cases. Remember, I presented the shared execution solution, so when you limited the number of messages to consume, then you just have to add new consumers to share the application solution, and that's it. You don't need to perform anything on the website, you don't need to create any partition. So that balance, when your consumer is up, it's magically available for listening new messages. And that's it, and then just a few seconds. Alright? That's elasticity of the consumer side. Now, so I say that no need to have a partition on the side, and remember that the key share substitution preserve ordering of all. Alright, now what if the limit is not on the consumer side, but is a worker by itself, because you have so many possible consumers that you add to scale up the broker by itself. Then I need to present the architecture of Pulsar. Pulsar has a very sophisticated architecture that has two layers. First layer is the processing of the compute layer. This layer is responsible for managing the connection between producer, consumer, worker, storage layer, etc. Basically, it's about processing. Whereas the storage layer is about, let's say, storage. So the computing layer is managed by what we call Pulsar Broker nodes. They are stateless because they only do processing. Whereas the storage is managed by bookkeeper nodes. Bookkeeper is another of the products, and that's a system. It's everything is Pulsar. So when you need more processing power because you limit the number of producers and you limit the number of consumers, then you just add some addition to add more workload, and that's it. When you need to scale up your Kafka cluster, and you add those, you may be forced to perform data movements across nodes. And Pulsar, right, speaks to you right as an name itself. So there is absolutely no data movement. You just pop up an instance of your kernel, and that's it. No data movement. Right? It's instantly available to accept new messages. Now, let's say that at this time, the limit is the storage capacity. My disks are almost full, so I'm going to add new storage capacity. Then I just have to add a new bookie node, and unlike Kafka, this new bookie node will be immediately available. This new bookie node can get new messages right away. You don't need to wait for rebounds or any data movement to be before the rush of the sonos. That doesn't happen with Pulsar. You add a new node, and now it's instantly available. Scalable. That's all. Very easy. So quick recap, if you limit the number of messages to be consumed, then you just have to have new consuming nodes, and that's it, the partition will more help. If you limit the number of producers or consumer, but also the number of tokens that we have to manage. For example, one single Pulsar cluster can handle more than 1 million tokens. And we are picking a version of the polygon Pulsar, we are able to handle 10 million tokens, or even more. Of the same person. So when you're limited to the number of processors and so on, then you just have to add new broker nodes, processing layer, and that's completely seamless, that's completely transparent for consumers and processors, and there is no performance impact, and no data movement. And if you limit the storage capacity, you just have to add new function codes, and that's it. We got our storage available, and the new function will be accepting the messages right away. And of course, this thing can also challenging with Kafka, you can also easily downscale of way to send an infrastructure cost. Right? Okay. So, as I said, Pulsar loves Kubernetes. So we implemented and provide what we call three operators for Pulsar. So we provide this under a free and simple to use and simple tools license. Token, not draft, some tools you need to check out documentation. Yeah. So these operators will help you manage your Pulsar Pulsar. That will help you take the action manage the installation of the web documents that you want, and you will basically declare how many documents you need and how many documents you need using some YAML syntax and this. We just confirm the Kubernetes supply on the YAML file, that basically the operator takes care of everything, and we scale the store. So we're still about to add scaling. Alright. Now, let's talk about how Pulsar stores messages. With Pulsar, a topic is not made up of partitions, it's made up of segments. So that's a very different storage model compared to Kafka. I would say that it's almost orthogonal model compared to Kafka. Right. So segments follow over time, right? And segments contain several messages, right? So a topic is basically a first infrastructure segments, a sequence of segments, and the segment is a 13 start structure. It is a sequence of messages. Okay? So you have two layers. So here with the example, I have a replication factor of 3. It means that every segment is stored on 3 different kilobits. So if I lose a kilobit, then I have lost in data. Because all the segments are replicated on at least 2 options. Right? This is how Pulsar is able to replicate your data using segments. Another cool thing with segments is that it enables you to offload those old segments to another storage system that is cheaper, like for example Amazon S3, cheaper compared to your push nodes. So that's the idea to offload those data, especially the core data, right? the older segments of the messages, and it may be able to offload them, and you need to offload them to external storage system, such as Amazon S3 or Google Cloud Storage, and now cheap compared to limited. So it's a terabyte or petabytes of messages using the offloaded system. And it's analytics completely BT with Pulsar. Okay. Now that you know what happens when I use a node, what happens when I use a data center? Well, with Pulsar, everything is somewhat fine actually. It does also provide built-in virtualization, a lack of problems. It means that with Pulsar, you can survive when you use a data center or you use a region. It's quite easy with Pulsar to have to install several replicas of an entire cluster, not just a single node, but an entire cluster. And Pulsar provide master slave application, but also bidirectional application across those instances. So when you lose a region, you can survive this. Okay, good, and it's built in. Okay, now I'd like to talk about another cool feature of Pulsar, which is multi-tenancy. What is multi-tenancy? The goal of the multi-tenancy is to share a single cluster with multiple teams in the same company. But those teams won't have access to data of their neighbors. Right? So you need to share a single cluster with multiple teams while providing data isolation. Right? I don't want the marketing department to get access to the entire department. But at the same time, I will need one single cluster to manage. It means even easier management because it can be centralized for the entire company. And we share resources, so we will end up with less nodes compared to what we use with Kafka, or we tend to, because with Kafka you have dependencies, so you tend to provision one cluster per department or one person. Team might do that, right? And that's not very cost effective. If you use an ActiveMQ feature, we end up with wireless nodes and you save and reduce cost. And this is completely built in, you could have to add anything about any add-ons of sorts. This is the issues too. Okay, so now we say, Julien was nice, Pulsar, durability, unification, redundancy, true elasticity, that's so sexy, but you know, Julien, in my company, I have a bunch of microservices that are returned in Kafka, the Kafka library, the Kafka protocol, right? Or the RabbitMQ protocol, and I can't afford to rewrite everything. Do you agree with me? I'm not big about budget trends. Well, I agree with you. Pulsar provides a compatibility layer. Let's dig into it. Remember, Spectre, you have the producer, the consumer, etc. When I presented that to you, I never say that the producer have to use the Pulsar protocol only. He can also use the Kafka protocol, the RabbitMQ protocol, or the Intensity protocol. Both on the producer side and on the consumer side. As well, with Pulsar, you can connect messages from IoT devices using Intensity, that you have MPT producers that will produce the topic, and you can consume those messages using the Kafka client. And necessary, you only have one topic. You don't have to second the implication across different technologies. Only one topic and not. All right. Pulsar benefits from a huge ecosystem. Handlers are represented them, but also many client libraries. If you want to code something using the Pulsar protocol, we use Shorefant library with that's the language that you use. You also have huge number of connectors, sources, and things that we never need to connect to Pulsar protocol to your existing ecosystem, to like the information system. You can write Pulsar functions, so the Pulsar mechanic to lightweight processing engine. That's so that enables you to write Pulsar functions in Java, Go, or Python. So this function will be with run on the workload nodes. Right? Python, but how many of them deployable models. And if you that's a simple lightweight model, but if you need more complex stuff, then you can use, for example, Apache Pulsar that works perfectly with Apache Pulsar. Right? So now I have to talk about the fact that Apache Pulsar, Apache Foundation, but solve the business. All those features that are presented in this presentation, multi-tenancy, geo-replication, true elasticity, etc., flooding, all of that is available. So if you download Pulsar and add this to Athens, you will get all of them. Okay? It means that you have a reduced vendor dependency on that vendor team. If you choose some benefit from the solution for individual without any vendor team. So if you choose to manage your cluster with easy, for example, or you choose to manage your cluster by yourself, in most cases, you benefit from always sort of terms and paper. Quick history. Pulsar was born in 2012 at Yahoo, our cloud service. Pulsar became open source 4 years later, then Pulsar became the Apache project. And now we're living in the small world Scalable, with many was a rapid and widespread adoption for the field number directors. So it's very important to understand that Pulsar is a quite mature technology part. Pulsar has been in production since 2012. Right? So Pulsar is a better tested. That's not so new. Okay? So Pulsar benefits from a vibrant community. with more than 600 contributors, about around 10,000 people on our Slack state of Libre that help you, and more than 1,000 organizations using Pulsar today. So the recap, Pulsar is a unified messaging platform, so you can use only one technology to do both messaging and streaming. Pulsar provides true elasticity, unlike other platforms. Pulsar provides very great durability and also offering with your data, zero storage. Pulsar is net security tenant, it is security tenant by design. Pulsar is geo-replicated by its design. Pulsar provides a compatibility layer that will help you migrate to Pulsar. And Pulsar are provided with source community. Right, so these are questions. At the end of the talk, I will help you if you could just download Pulsar and try that and put this thing to research. So within this QR code, and with this QR code, we also have several resources and comparison to Kafka and Pulsar. Alright, so the first one, to ask a question, get to hear it. So, the video is fine. Pulsar, of course, it's Phoenix will also be bad at answering you or if you it. Pulsar delete your Pulsar delete your data. Yeah, it's a bit like factory of server retention setting. That's quite different because the storage everything is insane, depending on the same model, it's the partial base that's set in base, or yes, you can use strong messages on both segments. You have to set up the retention loader, but you can also set up the maximum staff and also I think that you can also have a custom approach policy. I mean, you don't have to check, but yeah. When you're trying to did I answer the question? Right. Please. Congratulations. Okay. Was a question? Yep.
Can we cooperate like ActiveMQ drive?
You can do some versions in software chunks, and you can also do 100% in Apache feed. That's perfectly in Apache Pulsar. All right. Any question? Down.
Yes, we focus on manpower.
Very good question. I really need to question in branches. Yes, cannot be question.
So is there any benchmarks on towards like a skin that do like crazy number compared to what?
Yep. She can snap her, then you get a bit fast. Okay? Okay. I have was you the last one. I've said on to you. So, any question? Yep. A question here?
Thanks for the presentation. Just one question. Does Pulsar support data trust encryption and schema redis and Discord?
Yep. Pulsar also. For the sake of simplicity, I cannot print everything you exhaustive list of ASIC features, but yeah, Pulsar supports NetSecurity. So support the schema with NetSecurity. So you talk me to a component with that as that's in Pulsar. So you can check your message formats, you can do photograph and afterward you do some things in NetSecurity. And about the encryption, yes, Pulsar provides end-to-end encryption.
Even for the client libraries?
Even with what?
For client libraries.
Yeah.
And
yeah. For client libraries, yes, the client libraries provide end-to-end. Most of the client libraries provide end-to-end encryption.
Cool.
touch to the left. I think they're waiting 2 minutes. Questions? No question? Okay, so I don't say that which to me using this paper then for normal Steve and everything. I mean, I'd be very happy if you don't science right and we'll just to share feedback. One particular job is not only about promoting Pulsar, it's also about helping you on your job to Pulsar. Alright? Okay. Thank you.